Welcome to this video lecture for the course Nuclear and Particle Physics. Myself, Dr. S.S. Gomati, Associate Professor from the PG and Research Department of Physics, Sri Sharada College for Women, Autonomous, Salem. In this lecture, I will be explaining about elementary particles. Outline of my presentation: Introduction to elementary particles, types of interactions, classification and properties of elementary particles, quarks, flavors and colors, standard model of elementary particles, Gell-Mann-Nisijima formula, SU3 symmetry, and finally summary. Introduction to elementary particles. The branch of physics that deals with the property, interaction, and structure of elementary particles is known as particle physics. Elementary particles are the building blocks of all the matter in this universe. There are more than 100 elementary particles discovered so far. In particle physics, an elementary particle or fundamental particle is a subatomic particle that is not composed of the other particles. Types of interactions. In order to understand the behavior of elementary particles, it is important to understand the nature of interactions between them. Basically, there are four types of interactions. They are gravitational interaction, electromagnetic interaction, weak nuclear interaction, and strong nuclear interaction. So let us discuss one by one. First one is gravitational interaction. It is the weakest interaction that acts between all bodies having mass and is described by Newton's law of gravitation. The gravitational force acting between two particles of masses m1 and m2 is expressed as F is equal to g m1 m2 by r squared. Here r is the distance between the center of masses and g is nothing but the gravitational constant. The nature of interaction is attractive and it is due to inertia of the particles. Its range extends to infinity. It is responsible for motion of planets, and the gravitational attraction is approximately 10 per minus 38 times the strength of the strong nuclear interaction. And second one is electromagnetic interaction. It is charge dependent interaction, hence it operates on charged particles. It provides atomic and nuclear binding forces. It is of long range interaction and described by Coulomb's inverse square law. Proton acts as field particle of this type of interaction, and the electromagnetic interaction is weaker than the strong interaction but stronger than the weak and gravitational interactions. It is associated with electric and magnetic fields and is responsible for atomic structure, chemical reactions, the attractive and repulsive electromagnetic forces associated with electrically charged particles. And third one is weak nuclear interaction. And this type of interaction was described by Fermi in 1938 in order to explain beta decay and weak decay of elementary particles like pions, K meson, and some hyperons. It is very short range force, about meter. And the final one is strong nuclear interaction, and it is the strongest force in nature and is responsible for holding protons and neutrons together inside a nucleus. Hence, it occurs between two protons or two neutrons or between proton and a neutron. It is charge independent interaction. Its time of interaction is about a second. It is of short range force, about 2 meter. And this diagram represents the classification of elementary particles. Here we can see that elementary particles are divided into three main categories. They are photon, leptons, hadrons, and then electron, muon, tauons, neutrinos. Leptons are further classified into these four classifications, and this is again further divided, and we will discuss in detail about the classification of elementary particles in the next slide. Elementary particles are classified on the basis of their nature and properties. They are classified on the basis of mass, charge, average lifetime, spin, interaction, etc. The elementary particles mainly classified into three categories: photons, leptons, and hadrons. These names are taken from Greek, that is, hadrons means bulky, Leptons means light in weight. Photons represents quantum of radiations having energy E is equal to h nu, where h is Planck's constant and nu is frequency. And they travel with the velocity of light. They have stable, neutral, and zero rest mass. They have spin equal to 1 and they obey Bose-Einstein statistics. Hence, they are called bosons. Photons can be created and destroyed. It is the force carrier for electromagnetic interaction. So, coming to leptons, they are light in weight and they obey Fermi-Dirac statistics and hence they are called as fermions. They have spin equal to half and there are 6 leptons in total. The 3 charged leptons are called electron-like leptons, while 3 neutral leptons are called neutrinos, namely electrons, muons, tauons. Electron neutrino, muon neutrino, and tauon neutrino. So, electron is the first fundamental elementary particle discovered by J.J. Thomson. They have negative charge, they have stable and spin equal to half. The mass of an electron is approximately 9.109 10 per minus 31 kilogram and charge is equal to 1.6 into 10 per minus 19 coulomb. Muons are first discovered in cosmic rays. They have charge minus 1. They have spin equal to half. The muon is an unstable subatomic particle with a mean lifetime of 2.2 microsecond. Muons have a mass of about 207 times that of an electron. And tauons, they have been recently discovered and similar to the electron with a negative electric charge and a spin of half. Tau leptons have a lifetime of 2.9 to 10 per minus 13 second. All 3 neutrinos are stable but have no charge and spin equal to half. Each neutrino also has a corresponding antiparticle called an antineutrino. Neutrinos can be created in several ways, including in certain types of radioactive decay. Hadrons. So they are defined as strongly interacting composite particles and they are further classified as mesons and baryons. So meson means medium in mass. Mesons are unstable subatomic particles composed of one quark and one antiquark with the longest lived lasting for only a few hundreds of a microsecond. Mesons include pions, kaons, eta mesons. Pions have three subatomic particles pi naught, pi plus, and pi minus. Each pion consists of a quark and an antiquark. Pions are the lightest mesons because they are composed of the lightest quarks. They are unstable with the charged pions pi plus and pi minus decaying with a mean lifetime of 22 nanoseconds, and the neutral pion decaying with a much shorter lifetime of 8.4 into 10 to minus 17 seconds. So charged pions most often decay into muons and muon neutrinos, while neutral pions generally decay into gamma rays. Coming to kaons, which is nothing but k meson, they exist in three states: k plus, k minus, k naught. They are unstable and their mean life is about 10 per minus 8 seconds. Eta mesons have no charge, they are heavier than mesons, they are unstable, their mean life is less than 10 per minus 8 seconds. Baryons. So baryons means heavy, and this the baryon is a composite subatomic particle made up of three quarks. So baryons belong to the hadron family of particles. They have spin half. They include nucleons, hyperons, and resonances. So first one is nucleons. Nucleon is one of the particles that makes up the atomic nucleus. Each atomic nucleus consists of one or more nucleons, and each atom in turn consists of a cluster of nucleons surrounded by one or more electrons. They have spin half, and there are two known kinds of nucleon, the neutron and the proton. The neutron is a subatomic particle with a symbol N with no net electric charge and a mass slightly larger than that of a proton. The number of neutrons in nucleus is equal to mass number minus atomic number. And the second one is proton. It's a subatomic particle with the symbol P with a positive electric charge of plus 1, elementary charge and mass slightly less than that of a neutron. The number of protons in atomic nucleus are equal to the atomic number of atom. Hyperons. The hyperons are unstable and spin equal to half. They are discovered in cosmic rays. They are fermions. Their rest mass is greater than nucleons. They include sigma plus, sigma minus, sigma 0, omega, cascade, and lambda. Resonance. The resonance particles or resonances is that they are extremely short-lived particles. The lifetime of these particles is of the order of seconds. Traveling at the speed of light, these particles could only travel about meters or about the diameter of a proton before decaying. The next important topic is quarks, flavors, and colors. Quark is an elementary particle and a fundamental constituent of matter. Quarks combine to form composite and neutrons. Quarks have various intrinsic properties including electric charge, mass, color charge, and spin. There are six types of quarks known as flavors: up, down, strange, charm, top, and bottom. So, this diagram represents the six types of flavors and its mass, charge, and spin of each flavor. And here, this is again quarks, which is nothing but the combination of the particles. And this table represents the SU3 triplets of quarks. So, for example, a quark, the isospin, the Z component of isospin, strangeness, charge, baryon number, hypercharge, and parity, and they are given for the three quarks A, B, and C. And this second table represents the generation of baryons from quark combinations. That is, when you, for example, if you want to see the particle proton here, it consists of two A quark and one B quark, and therefore the corresponding components of isospin and everything are given in this, depicted in this table. And this is nothing but a standard model of elementary particles. Here you can see the three generations of matter, that is elementary fermions, and three generations of antimatter, elementary antifermions, and interactions or force carriers between, that is the elementary bosons. So now here you can see the up quark, which has got mass 2.2 million electron volt, then charge 2 by 3, spin half. And these are nothing but the quarks, and the corresponding antiparticle for up is anti-up. For charm is, it is anti-charm. So in this way you can very well understand the various types of elementary particles and the combination of quarks which makes that particular elementary particle. And this is eightfold way Gelman-Isijima formula relating electric charge to spin, that is isospin. Q is equal to I3 plus half into B plus S, where B represents the baryon number, S is strangeness, and Q is charge, which is nothing but the electronic charge, and I3 is the Z component of isospin, and Y is equal to B plus S is called a hypercharge. And quark triplets, Gelman and others proposed that one might build all the experimentally observed particles from just three quarks: up, down, and the strange. So one way to build the particles is to think of the quarks as vectors in a two-dimensional imagined space with y along the vertical axis and I3 along the horizontal axis. And coming to the main topic, which is SU3 and SU2 symmetries. They are nothing but the mathematical frameworks used in particle physics. SU3 symmetry explains the strong interaction which governs the behavior of quarks and gluons in quantum chromodynamics. SU2 symmetry is part of the electroweak interaction unifying electromagnetic and weak forces crucial for understanding particle behaviors and interactions. SU3 symmetry. Eightfold SU3 symmetry or theory is a generalization of the theory of isospin. This stands for special unitary group in three dimensions. The term three dimensions refers to the three basic states which make up the fundamental representation in this case. In a three-dimension unitary group, there are in general 3 by 3 is equal to 9 operators, but the restriction of special reduces the number in 8. The group is then said to have 8 generators instead of 9 operators. Gelman has referred to the resulting group of symmetry operators as the Eightfold Way, named for Buddha's Eightfold Path to Nirvana, comprising 8 right actions. The three of the generators apply to three components of isospin, as in SU2, and a fourth is associated with hypercharge. The remaining four also involve hypercharge in a different way. Application of group algebra showed that the SU3 symmetry should give rise to 6 supermultiplets containing 1 or 8 or 10 and 27 members. 8 and 10 members group are of particular interest, and we will be discussing the members containing 8 elements, that is group containing 8 members or 10 members. And this diagram represents the SU3 symmetry performed in baryon octet, boson octet, and baryon decuplet. In baryon octet and boson octet, you have got 8 members in the group, that is 8 operators, whereas in baryon decuplet, you have got 10 members. So 8 and 10 members group of members of the group are important for discussion. So when you consider this octet case, here one triplet with y is equal to 0, t is equal to 1, one doublet here with y is equal to 1 and t is equal to half. You can very well see the representation here. Hypercharge is taken along the y-axis, and the third component of isospin, which is I3 or T3, is taken along the x-axis. And here you can represent the electric charge Q. And here if you take, for example, K0 and K plus, so both have got the hypercharge as 1, whereas their charge is equivalent to, here for the K0 the charge is 0, for K plus the charge is plus 1. So now this doublet with the y is equal to 0, y is equal to 1 and t is equal to half here. Whereas when you go for this doublet, that is y is equal to minus 1 here, here it is minus 1, here it is k minus and k naught. In baryon octet also, there are two doublets and then one singlet, which is lambda, and three triplets, sigma minus, sigma naught and sigma plus, and they have a hypercharge of 0, and sigma minus and psi minus, they have got electric charge minus 1, whereas these four elementary particles will have electric charge as 0, and here the lambda is the particle which has got hypercharge 0. So this baryon octet and boson octet, they belongs to 8 members group. And here you have got one singlet, one doublet with y is equal to minus 1 and t is equal to half, one doublet with y is equal to 1 and t is equal to half, and one triplet with y is equal to 0 and t is equal to 1. So the totally 8 members. So here also 8 members. And coming to the baryon decuplet, here you will be having one quartet, one triplet, one doublet, and one singlet, which is omega minus hyperon. And here also you can find out some similarities, that is these four particles will have electric charge as minus 1, and these three will have the electric charge as 0, and this two will have electric charge as 1, and these will have electric charges plus 2. Here also we have taken hypercharge along the y-axis, and the third component, that is the z component of the isospin, that is a spin, is taken as T3 here. And coming to the summary, elementary particles are the fundamental constituent of all the matter in this universe, and we discussed about the four types of interactions like gravitational, electromagnetic, weak nuclear, strong nuclear interaction, and they are all needed to explain the behavior of elementary particles. And the elementary particles are mainly classified into three categories. and we have seen in detail about the photons, leptons, and hadrons. And quark is nothing but an elementary particle and also a fundamental constituent of matter. Quarks combine to form composite and neutrons. And quarks have various intrinsic properties including electric charge, mass, color charge, and spin. And there are six types of quarks known as flavors: up, down, strange, charm, top, and bottom. And we have also seen the standard model of elementary particles and also the various combinations of quarks to get the elementary particles. And coming to the special unitary operator, that is SU3 symmetry, explains the strong interaction which governs the behavior of quarks and gluons in quantum chromodynamics. And SU2 symmetry is part of the electroweak interaction unifying electromagnetic and weak forces crucial for understanding particle behaviors and interactions. And finally, multiple choice questions are given to make yourself familiar with the concepts discovered so far. So you can very well check your answers given by answering the questions. And this will help you to understand the subject in detail. And these are the references. Thank you.